right, in this lesson, we're going to be talking about function operations. A lot of this is stuff that we've already done, but the notation is going to be different. So they're going to give us two functions. So in problem number 1, we have f of x that is at 3x plus 4, and g of x, which is x squared minus 5x plus 2. And it wants us to identify the rules for the following functions. That means just come up with the equation that goes with the operation that they're telling us to do. So they want us to take f and add that to g. All right, that can also be written as f of x plus g of x, or f plus g of x. All right, so either way, all three of these are the same thing. So when I'm adding two things together, I don't have to worry about any distributing or anything like that. So I'm just going to take f of x, which is 3x plus 4, and add that to g of x, which is x squared minus 5x plus 2. And I'm just going to combine like terms and put this in order. So I have x squared, 3x, and negative 5x make negative 2x, and then 4 and 2 make 6. Now, it's not asking us about the domain and range, but let's address it. So if you don't have an x in a denominator, that would cause that denominator to be equal to 0, or you don't have x under an even root that would cause you to have an imaginary number by having a negative number under that root, then you're not going to have any restrictions on this domain. So if you look at f of x is just 3x plus 4. All right, that's linear. I don't have an x in a denominator or an x under an even root, so I have no restrictions there. Same thing here, no restrictions. And then when I add them together again, no restrictions. All right, so our domain would just be all real numbers. Now, when I'm subtracting, I do have to worry about this minus that's in front of g. So whatever is in g is going to have to get distributed with this -1. So I don't have to worry about anything being distributed to f. But behind this minus sign, I have 3 terms within g that are going to have to get that negative distributed. So let's distribute the negative. That gives me negative x squared, positive 5x, and negative 2. And now I'm ready to kind of put everything together and put it in order. So I have negative x squared, 3x and 5x make 8x, and 4 and negative 2 make 2. Again, no restrictions on any of those domains. All right, number 2. Again, we're just going to add f and g. So I have 2x squared plus 7x minus 1. And then I'm adding that to g, which is 3 minus 2x. I'm just going to put those in order and combine like terms. So I have a 2x squared, 7x and negative 2x make 5x, and negative 1 and 3 make positive 2. And again, no restrictions on those domains. All right, I'm going to kind of kill 2 birds with 1 stone here, and I'm going to take my f of x, which is 2x squared plus 7x minus 1, but I'm going to go ahead and distribute that negative as I write down g. So I have a positive 3, now I have a negative 3. I have a negative 2x, now I have a positive 2x. It's kind of doing 2 steps in one. All right, if you can't do that, then just write it down and then distribute just like we did on 1b. All right, so I have 2x squared, and then I have a 7x and a 2x, which makes 9x, and a negative 1 and negative 3, which makes negative 4. All right, number 3, the demand D in units sold for a company's new brand of cell phone at price X in dollars is D of x equals 5,000 minus 10x. The cost to manufacture the cell phone is C of x equals 2,200 plus 80x. What is the company's expected profit from cell phone sales in terms of the price X? So you do have to think about a couple of things, okay? Number 1, your price can't be negative. So those are things to think about. And then you also have like your demand and things like that. You know, you can't produce as much as you want. So they do tell you that profit is equal to the price times the demand minus the cost. They gave you all of that. So they told you the price was X times the demand. Well, the demand is 2 terms, so we need parentheses. 5,000 minus 10x minus the cost is also 2 terms, so you need a parenthesis. 2,200 plus 80x, and now you just have to simplify. So I'm going to distribute this x. That gives me 5,000x. And then x times negative 10 would be negative 10x squared. Then I have to distribute this negative, so negative 2,200 minus 80x. And I'm going to make this p of x for profit and put this in order. So I have negative 10x squared, 5,000x minus 80x would be a positive 4,920x. And then you have that minus 2,200. So I could plug in any price and figure out what my profit would be just from that equation. All right, we're going to identify the rule and domain for f divided by g for each pair of these functions. So f is going to go on top, g is going to go on the bottom. So I have x minus 7 on top and 2x squared minus 13x minus 7 on the bottom. All right, now just like in the past when we've divided things, we know that we can sometimes simplify if we have matching factors on top and the bottom. So I'm going to go ahead and factor that trinomial on the bottom. I have a 2 in the front, so I'm going to multiply that times the back, do the illegal move. That gives me 14. Since I have a minus in the back, I know I have one positive and one negative, along with my x times x for my x squared. And the two numbers that multiply to make 14, that subtract to make 13, would be 14 and 1, and I do need a negative 13, so 14 will have to be negative and 1 will be positive. And then I'll undo that illegal move by dividing both of these by 2. 1/2 does not reduce, so I'm going to take that 2 and pull it in front of the x. So that gives me 2x plus 1, and then 14 divided by 2 is 7. So on top I have x minus 7. On the bottom I have 2x plus 1 times x minus 7. So I can cancel x minus 7. That leaves me with 1 over 2x plus 1. Now I do have to think about the domain. So if you look at f of x, no restrictions because there's no x in a denominator, no x under an even root. Same thing for my g of x. However, when I divide them, g is now in the bottom. So I have to worry about those two factors in the denominator. So if you set those two factors equal to 0, I would subtract 1, divide by 2. So I know that if I plugged in negative 1/2, I would get a 0 on the bottom. And if I plugged in 7, so I know that my x cannot be negative 1/2 and 7. I do have those two restrictions on that domain. All right, number 5, f is going on top. G is going on the bottom. And I have a trinomial on top, so I will factor that. There's a minus in the back, so I know I have 1 plus and 1 minus along with my x times my x for the x squared. And the two numbers that will multiply to make 18 that subtract to make 3 are 6 and 3. And since I need that 3 in the middle to be negative, 6 will be negative and 3 will be positive. And then I can cancel those x plus 3's and I'm left with x minus 6. And I do have to think about those restrictions. So no restrictions on my f of x, no restrictions on my g of x, but the second that I divide them, my g of x is in the bottom. So I need to set that x plus 3 equal to 0. So I know that if I were to plug in negative 3 on the bottom, that would give me a 0 for my denominator, which is a no-no. So x cannot be negative 3. So I just have that one restriction. All right, on number 6, again, f is going on top. G is going on the bottom. And I'm going to factor that denominator. Again, one positive, one negative, x and x. And what multiplies to make 6 that subtracts to make 1 would be 2 and 3. And I need that 1 in the middle to be negative. So 3 will be negative, 2 will be positive. I can cancel the x minus 3. That leaves me with 1 over x plus 2. And I do have two factors in the denominator. I have no restrictions on the f or the g in and of themselves, but I do have two factors in the denominator, so I set both of those equal to 0. So x cannot be -2 and x cannot be 3. So 2 restrictions on our domain there. All right, so moving on to function composition, this is pretty much where one function is going to go in for another function. So they've given us f of x and g of x. They want us to find the values of f of g of 0, f of g of 3, and f of g of -2. So you are going to start in the middle and do this middle part. So we're going to start with the g of 0. So when I say g of 0, that literally means I'm going to go to function g and I'm going to plug in 0 for x. So function g is x plus 1, so I plug 0 in for x plus 1 and I get 1. All right. Now, what that means is g of 0 equals 1. So you can take out g of 0 and replace it with 1. Now you're finding f of 1. That means I go to the f function and plug in 1. So 1 squared is 1. So that means that f of g of 0 is equal to 1. So we're going to start with g of 3. So we go to the g function and plug in 3. 3 plus 1 is 4. So g of 3 is the same thing as 4. Now we're doing f of 4. So I go to the f function and plug in 4. 4 squared is 16. So I know that f of g of 3 is equal to 16. So we're going to start with g of -2. I go to the g function, plug in -2. -2 plus 1 is -1. So g of -2 is the same thing as -1. So now I'm doing f of -1. So -1 squared is 1. So I know that f of g of -2 is equal to 1. Now, it's kind of tedious to go and do one number and do another number and do another number. So instead, it's easier if we can come up with a rule for that. So we're going to start with g of x, and we're going to plug that into function f. So what I like to do is the function I'm plugging into, I like to take that function, and everywhere we have an x, I'm going to put a big parenthesis. So I have parentheses because it's x and then squared. And then what am I replacing? I'm replacing that x with g of x. Well, we saw up here g of x is x plus 1. So I'm going to replace that with x plus 1. And then I'm going to do the math. X plus 1 squared, that's x plus 1 times x plus 1. So if I do this, x times x is x squared. Anytime you square something, the middle numbers are the same. They get doubled. So you have a 1x and a 1x. That gives you 2x. And then 1 times 1 is 1. And that is f of g of x. Now, the fun thing about that is you now have a rule. So anytime you wanted to know what it would be when you plugged in that number, you could have used the rule. So, for instance, on g of 0, the f of g of 0, if I plugged in 0, 0 squared is 0. 2 times 0 is 0. Plus 1 is 1. I could do the same thing with 3. 3 squared is 9. Plus 2 times 3 is 6. Plus 1, that gives me 16. So it's easier to have the rule so that you don't have to do it individually every single time. So on number 8, we're going to start with g of 2. So I go to g and I plug in 2. So 3 times 2 is 6. So g of 2 is the same thing as 6. Now I'm doing f of 6. So 2 times 6 is 12, minus 1 is 11. So f of g of 2 is equal to 11. All right, so let's find the rule by plugging g into f. So I'm going to write f down. That would be 2 times something. What was that? Minus 1. Well, the something is the g, which is 3x, because remember we're taking g, plugging that into f. That gives us 6x minus 1. So f of g of x is equal to 6x minus 1. So a composite function is the result of applying the rule for one function, f, to the rule of another function, g. The new rule is denoted as f of g. Now, these are the same thing. All right, that looks like the word fog. It's not. It's like a little, looks like a degree symbol kind of thing, but it's not up in the exponent area. So both of these are exactly the same. All right, so the operation, we're looking degree symbol, that forms a composite function is called composition of functions. All right, the domain is the set of all real numbers x in the domain of g such that g of x is also in the domain of f. So the domain of the composition is the intersection of the domains of g and f of g, but not f. Okay, so what is the rule for the composition f of g of x? So we have f of x is the square root of x plus 7, and g of x is 2x minus 5. So we're going to do f of g of x. Remember, that's the same thing as this. They are just written differently. So I'm going to write down f, but I'm going to leave a blank spot here. Now, there's nothing attached to this x, like there's nothing being multiplied. It's not being, raised to a power. So I really don't need parentheses there. So I'm going to leave it blank there, and then I have my plus 7, and I'm replacing that with g. So g goes in for x, and then I'm just going to simplify. So I have 2x, and then negative 5 plus the 7 gives me 2. So now let's talk domain restrictions. If you look at f of x, you do have an x underneath that root. So you're going to set what's underneath the root equal to 0. So I know that if I were to plug in negative 7, I would get a 0. So now you need to think about numbers that will avoid having a negative underneath there. So I like to pick a number that's bigger than that number. So let's just go with 0. All right, 0 is bigger than negative 7. So if I plug 0 in underneath right here, 0 plus 7 would give me 7. That's a positive number. So that means that all of my numbers are going to have to be numbers that are greater than or equal to the negative 7. All right, I don't have any restrictions on g. But I am back to having something underneath my root in my final composition here. So I'm going to take that and set it equal to 0 and solve. So I subtract 2, divide by 2, and I get negative 1. So again, I'm going to think about numbers that are bigger than negative 1. So let's try 0. 2 times 0 is 0, plus 2 is 2. That's a positive number, so I know that I need numbers that are greater than or equal to negative 1. If you chose something smaller than that, say negative 2, you would get 2 times negative 2 is negative 4, plus 2 is negative 2. You would have negative numbers, so we don't want that. We want positives. So here's the problem. I have a domain for my f of x. I have a domain for my composition, and they are not the same, okay? You want the overlap of those two domains. So think of it like a number line. We'll throw it back to Algebra 1 here. Let's say I graph x is greater than or equal to negative 1. That would be shaded to the right. All right. And then let's say I do the negative 7. Again, shaded to the right. They start overlapping right here. So the overlap is actually the x is greater than or equal to negative 1, because all of those numbers in that domain will work in both the square root of x plus 7 and the square root of 2x plus 2, whereas the ones in the x is greater than or equal to negative 7 won't. All right, the negative 7 all the way up until we get to negative 1, all of those are not going to work in the 2x plus 2 part. They give you negatives. So you want the overlap. So if you have to draw yourself a little number line, then draw yourself a little number line. So our domain is x has to be greater than or equal to negative 1. All right, number 10. Again, we're doing f of g of x. So we're going to plug g into f. So I'm going to write f down, but everywhere that I have an x, I'm going to put parentheses. And then I'm replacing those x's with g of x. So 4 minus x, 4 minus x. So I'm going to take 4 minus x times 4 minus x, because that's what 4 minus x squared is. So 4 times 4 is 16. And then since these are the same, I have a negative 4x and another negative 4x. That's negative 8x. And then negative x and negative x, that gives me positive x squared. There's nothing to distribute here, so I just have 4 minus plus 4 minus x, and then plus 2. So I'm going to go ahead and write my composition notation and put these together, combine like terms. So I have an x squared, negative 8x and negative 1x make negative 9x. 16 and 4 make 20, plus 2 is 22. And we have no restrictions on our domain because there's nothing anywhere in any three of these that requires us to take a look at what x cannot be. All right, 11, we're identifying the rules for f of g and g of f. So we're going to do it both directions. So let's start with f of g of x. So we're going to plug g into f. So I'm going to put a parenthesis in my f where the x is and replace it with g, which is x plus 1. So we're going to have to take x plus 1 times x plus 1 times x plus 1. So do the first two. X times x is x squared. You have a 1x and another 1x. That makes 2x. And then 1 times 1 is 1. And then we're going to take that times the x plus 1. So x squared times x is x to the third. X squared times 1 is x squared. 2x times x is 2x squared. 2x times 1 is 2x. 1 times x is 1x, and 1 times 1 is 1. So now I'll just combine like terms and put this in order. So I have an x to the third. 1x squared and 2x squared make 3x squared. 2x and 1x make 3x, and then plus 1. And no restrictions on my domain because I don't have x in the denominator. I don't have x under an even root. So no restrictions at all on my domain here. And then we're going to do this backwards and do g of f of x. So this time we're plugging f into g. Now g just has this x right here with, it doesn't have anything being multiplied by it. It doesn't have any powers, so we don't need parentheses around it. But I'm going to replace that x with f of x, which is x to the third, plus 1. And again, no restrictions on my domain and nothing to simplify there. All right, so number 12. All right, again, I'm going to do both ways. So I have f of g of x. Let's start with that one. So we're going to plug g into f. Now, again, I just have this single x under the root, so I really don't need any parentheses there. And then I have plus the square root of 7. Nothing to reduce there, but we do need to, or simplify, we do need to talk about the restrictions. So there's a single x under this root. So that means x has to be greater than or equal to 0. I'm going to set this one equal to 0 and solve, because that's always our starting point. So to get a 0 under the root, I have to be at 5 halves. And I'm going to think about this. So 5 halves, that's 2.5. I'm going to pick a number bigger than that. 3. 2 times 3 is 6. Minus 5 is 1. So numbers that are bigger than that are going to give me positive. So x has to be greater than or equal to 5 halves. And then remember, we need the overlap of these. So if you have 0 and then you have 2.5, one goes this way, one goes this way. They start overlapping here at the bigger one. So I know that x has to be greater than or equal to 5 halves. All right, and then we're going to go ahead and do g of f of x. So I'm going to write down g and put a parenthesis where the x is, and then replace it with f, which is square root of x plus square root of 7. And then I'm going to simplify. So I have 2 times the square root of x plus 2 times the square root of 7 minus 5. There's nothing that I can combine there. All right, but I do have that x underneath the root. So I know that x has to be greater than or equal to 0 to avoid those negatives. All right, number 13. A clothing store posts discounts on social media. Followers are allowed to use multiple discounts. They simply need to tell the cashier in which order they want the discounts. On their next trip, the store in which order should they ask for the discounts to save the most money? All right, so I know that I have 2 coupons, all right? One of them is $5 off my next purchase. The other is 10% off the next purchase. Now, if you use some common sense here, you would figure out that you really do need to do 10% off first because you'd be taking 10% off a larger amount and then take your $5 off. All right, if you do the $5 off first, you're going to decrease the total amount and then you'll be taking 10% off of a smaller number. All right, but I'm going to show you how compositions work here. So let's come up with equations for both of these. So I'm just going to say f of x is the $5 off. So let's say the price of my item is x. If I'm getting $5 off, I'm going to take away 5. All right, now we need an equation for 10% off. Again, you have your original price and you're taking away something. The something that you're taking away is 10% off the price. So that would be 0.1 times the price. So if I combine those like terms, that would be 0.9x. In other words, you're paying 90% of the price of the item. Okay, so I have my 2 things. So let's start with 10% off first, followed by the $5 off. Okay, so I want you to think about this. If I have f of g of x, I do g first and then I do f. I start with the middle. So if I want to show 10% off first, that means that this equation needs to be the 10% off and this equation needs to be the $5 because I'm going to do 10% first and then $5. So I'm going to do f of g of x because I do want my g of x first. All right, so I'm going to write down f. F is just x minus 5, so I'm going to plug in the 0.9x for the x minus 5. All right, I have nothing to simplify there. Okay, and then let's do the $5 off followed by the 10%. So that would be g of f of x. So I'm going to write down g of x, but I'm going to put a big parenthesis where that x is and replace it with f. And then I have to distribute. So 0.9 times x is 0.9x. 0.9 times negative 5 is 4.5. So if you think about this, you're going to get 90% off your item and then only get to subtract $4.50, whereas here you would get to subtract the 5. All right. And 90% of the bigger number is going to be bigger anyway. So this right here is the better deal. The 10% off is the better deal. All right, suppose 2 functions, f of x and g of x, are only defined by the ordered pairs that are listed below. Find the ordered pairs that comprise f of g of x. All right, so they want you to do f of g of x. And this is written different than the other ones, so let's talk about it. Every point is an input and an output. So for instance, this point right here, if I input 5, I get 4 as an output. So you could say g of 5, so if I input 5, I get 4. That would be like saying f of g of 5. Okay, so if I input 5, I get 4. Now I do f of 4. Okay, so f of 4. So I go to my function and I find the input of 4 and the output is 1. So I get 1. That means that when I put 5 in originally, I get 1 as an outcome. All right, so now we're just going to go to the next point. So we have g of 3 is equal to, my output is 6. Now I'm doing f of 6. So I go to my function f, I locate an input of 6, and the output is 7. So when I input 3 into g, and then my output of f is 7. All right, so let's go to the next point. We have 1 with an output of 5. So g of 1 is equal to 5. Now I'm going to do f of 5. So I go to an input of 5. My output is 2. So the point would be 1, comma 2. Input, output. All right, and the last one is g of 2 equals 10. So input, output. Now I'm doing f of 10. So I go to an input of 10. The output is 8. So the point would be 2, 8. And those would be the ordered pairs that comprise f of g of x. Now, it does happen every now and then that an output you get may not be in as an input of f. So for instance, like here I got 10. Let's say this point was not here. Then I just wouldn't have a point that goes with f of g of x because the output of g was not an input option for f. So those would be my 4 ordered pairs that comprise f of g of x.